The last question in section 3.4, polynomial functions graphs. We are given a polynomial function f of x is equal to x minus 3 quantity to the third power times the quantity x plus 1. Sketch the graph of the polynomial function. When we follow the standard procedure, we want to graph the x-intercepts first. You're going to set each factor equal to 0 to find the x-intercepts. If you set x minus 3, that's one of the factors, equal to 0, you get x equals 3 as a 0 of the polynomial function. And set x plus 1 equal to 0, you get x equals negative 1. These are your x-intercepts. On the graph, you have the graph is going to cross through at 1, 2, 3, at positive 3, and at negative 1. Now what it does in between here, we can determine by making a table of values. X and f of x. We can plug a value, since this is negative 1, I would probably plug in negative 2 for x, plug that into the original function to find the y. I would choose possibly a couple points in between here, 0, 1, 2. And we know it's going to touch or cross the x-intercept at 3, and then we're going to, let's look at 4. So here we have 5 additional points that we're going to graph in addition to our 2 x-intercepts, and that's going to give us a pretty good idea of what's going on with the shape of the graph. Plug negative 2 into the original equation. Now you can do this with any calculator. But I would do on the graphing calculator, you plug in negative 2 minus 3, all of that to the third power, times negative 2 plus 1, just went too fast, plus 1, and simplify, you get 125. So when x is equal to negative 2, the f of x is equal to 125. I simply plug in negative 2, so negative 2 minus 3 is negative 5. It's negative 125 times negative 1, you get a positive 125. If you plug 0 into this, 0 minus 3, that's going to be negative 3 to the third power, times 0 plus 1 is times 1. And that we get negative 27. So when x is 0, we get negative 27. If we plug 1 into the function, we get 1 minus 3 to the third power times 1 plus 1. And that will give us negative 16. Plug 2 in for x. And you get negative 3. And then finally plug 4 in for x. And simplify. And you get 5. So this should be enough points for us to get a decent idea of the shape of the graph. This is negative 2 goes all the way up to 125. 0 goes all the way down to negative 27. So we're going to have to choose a large enough scale on the y-axis so that we can see all of those values. So if I go by 50s perhaps, if I go 50, 100, and then 150, that is going to choose be a large enough scale so that we can see this point here. And then so it'll be negative 50, negative 100, and so on. And we can plot those points from the table, and -2, a positive 125, -1, 0, 0, -27, 1, -16, 2, -3, and 4, +5. So that should possibly give us enough points so that we get a decent idea of what this graph looks like. If you need to do another point, say when x equals 5, you'll see that the graph is going to continue to move upwards. We look at the choices here. That looks most like choice A. Another thing you can do if you have the graphing calculator is you can plug in the original polynomial function, press the y equals, and enter the equation exactly how you see it with the parentheses. And then I usually start off with a standard zoom. When you do that, however, you don't see all that detail in the graph. And if you notice all the choices, the y goes all the way up to positive 150 and negative 150. So if you change your window and change the y min, the minimum y, the lowest y to be negative 150, and the y max to be positive 150, you'll begin to see a graph that looks more like the choices given. And then I press graph, and you see that this graph does look a lot like choice A. It looks similar to how we graphed it without a calculator by making a table of values and plotting those x-intercepts.